Welcome to USAR 2021. We are truly happy to connect to all of you globally. This meeting is live streamed. We are very grateful to all our sponsors who make this conference possible. Today's sponsor is our studio. Let me introduce myself. I am Aditya Upadhyay, geospatial data analyst at INCLABS in India. Today, we have Meenakshi as the keynote speaker for R in Action. Meenakshi is an air quality and environmental health researcher from India, currently living in Taiwan. She works on projects based in India and in the US. In 2017, Meenakshi co-founded a women-owned consulting organization, INCLABS, with a focus on providing reliable data for environmental health projects and education focused on global grant challenges. She is passionate about reproducible research and enjoys teaching R and stats. Meenakshi earned an MPH in environmental health from University of Washington, Seattle in 2015 and an MS in biomedical engineering from University of Alabama at Birmingham in 2009. Her work on pollution inequities was recently featured in the New York Times. Before we start, requesting all attendees to ask questions and upvote questions in the Q&A feature here. Welcome, Meenakshi, over to you.
Thank you. Thank you so much, Aditi. I will share my screen now. Please confirm when you see it. Are you able to see my screen?
Yes, perfect.
Okay. Thank you so much. And hello, everyone who is here. Thank you so much for joining. I'm really grateful to user for this amazing opportunity. Today, I'm going to talk about how we use R to answer questions about air quality. And much of the work that I will present today is led by Aditi. We have just been very fortunate to get a chance to work with her on these projects. So yeah, I'll get started. Okay. So we are a small team, interdisciplinary team with very different backgrounds from GIS, atmospheric chemistry, environmental health, basic science, and we have all come together to work on air quality projects. The reason I named our talk today, Can We Do This in R, is because we've all had very different R journeys, and we are all in very different places, our team, in very different places. We have had no, like many R users, we have had no formal training in R, and we have learned it on the job. And so every time we have a new computational question, we have a new visualization challenge, we ask this because we have not done this before. Can we do this in R? And for the past 4 years that we have worked in R and on these projects, the answer has always been like a resounding yes. Yes, we can do this and we can do more. So this talk is about that, just a sample of what all we do in R. And yeah, so to specifically what we do at INCLABS is we measure air quality to answer questions like, is one block dirtier than other? Is one season different than other in terms of concentrations? Do low-cost instruments or consumer-grade instruments, do they answer questions reliably when compared to more expensive reference grade gold standard instruments? And if they don't, can we apply statistical corrections to make the measurements more reliable or more informative? Can we adapt cutting edge methods from different contexts, mostly developed country settings, to low or middle income resource settings like India when it comes to monitoring? And we also analyze national level household surveys on energy use, indoor air pollution, and we work on building models for pollutants using different sources of data with satellite and ground data. So I'll spend the next few minutes in contextualizing, giving a background on how we collect data that we then analyze in R. So it will be, bear with me for some air quality primer. When it comes to measurements, there are two main types of air quality measurements. One is stationary monitoring. So these are two duplicate high-end sensors installed on a rooftop. And this is typical of how air quality stationary monitors are placed. They measure your ambient air and give the concentration at that particular site. What is becoming more and more popular with time now is mobile monitoring, where sensors are placed in a car and then or any moving platform, and then they are used to map pollution at street level. So what you see here is a Google Street View car. So these Google Street View cars are the same cars that Google uses for maps, for mapping your street. And in some countries, a few cars from the fleet have these really sophisticated air quality instruments fitted on them, so that while the street is being mapped, air quality on those streets are also being measured. In India, Google Street View cars are not allowed for privacy and security reasons. So we have adapted this technique working with the same team for our Indian settings. This is an example of what a stationary monitoring network looks like. So this is a map of Bangalore where we work, which is in South India, a city in South India. And all these circles, each circle is one stationary monitor, and the color and the number here gives a concentration of a particular pollutant there. So this is what a network looks like, many sensors distributed all over the city. And if you have enough sensors in a particular region, then it can give a city scale or a macro scale idea of what the pollution like that there is. So this is one of our stationary monitoring projects. And this is a schematic of our mobile monitoring project. So what goes in our the car that carries the sensors. So now we are coming to these different data sources that we have to combine together to analyze. So there are different groups of devices. We have portable instruments for air quality. Each instrument is for a particle or a particular gas. Now, since we are in the air, and since we are moving on a mobile platform, we are collecting spatial data, and that spatial information is very important. We have a GPS for location information. We also use probes for weather conditions, so to measure humidity in the air, because that impacts our readings. That impacts the readings when you're measuring particles, especially. So these are all the different instruments that go into the mobile platform. And one of the main products is building a street level pollution map like this on the right, which is similar to your Google traffic maps, except the color here, instead of traffic, it denotes the level of the pollutant. So the darker street means they are more polluted than the lighter or the blue streets. So what this setup means is that each of these instruments have their own data frame, like they have their own data download method, and from the point of view of analysis, a different data frame in a different format, with the timestamps in different format, and such layers of complexities before we get to analyze them. So this is the inside of our moving platforms. It's less fancy than a Google Street View car, but what we have done here is removed the back seat of a car, fitted it with these metal shelves, and all the instruments that I showed in the previous slide, they're all secured in this blue bin, and they have inlets coming out of them, which measure the air and the particles inside. And the laptop here is used as a logger, because all instruments do not log data in the instrument, so they need additional laptop. So this is our data collection setup, and this is how we collect the data that we later analyze in R. So this is what it looks like in practice. We take this car out on the road and make repeat measurements several times. But sometimes it looks like this. So this is an image of one of our roads where we had planned to take the car for measurement. And there is this roadblock. As you can see, the road is dug up. It's typical. It's a very common sight in many Indian cities. It's unplanned, unannounced, and we don't know when we would be able to go back on the road. So it is indefinite. So all that to say is, if you have collected field data, you know that it is complicated. There are many things that are out of control. It can be chaotic. But once we have surmounted those and finally painstakingly collected the field data, using R in the next step for data analysis really allows us real control, and the flexibility that R provides is very, very empowering. So now from here, I will show a few slides on packages, R packages that we use, specific packages that we use, and what do we use them for. So we all love tidyverse. So for all our data cleaning tasks, we use many tidyverse packages, and for plotting as well. We have, as you saw, the different sources of data in the mobile monitoring platform. They all have timestamps. And so it's very useful to use reader and read_CSV functions to read those in, because it automatically parses the date time objects. So you don't have to specify separately that this is not a character and it's a date time column. So that's very super useful. ggplot for all our, that's our first go-to for all our visualization plotting tasks. Then we are always working with a lot of big data. We are collecting high frequency data per second or per minute for many, many, many days. And so using per and map functions instead of the for loop whenever we can makes the analysis more efficient, makes our code faster. So that's very helpful. And beyond tidyverse, there are some packages that we have we find particularly useful for our analysis. So first is consistent timestamps using Lubridate. So we have our data from different devices, and our first step is to match them together, to join the data sets together based on the timestamps. So the location data with the pollutant data, and with the weather data. Now, for this, the timestamps need to be consistent so they can be matched. So the timestamps could be of different formats. They're just based on device manufacturer preferences. Sometimes the timestamps are in different time zones, and that's because that depends on sometimes where the instrument is manufactured, or some manufacturers prefer just UTC standard time. So it is different from the Indian standard time that we would be using or would be counting on for analysis. So for all of this, Lubridate, some functions in Lubridate are really, really intuitive. For us, for example, parsing date times with the YMD_HMS set of commands. If you have not used this before, it's year, month, day _hour, minute, seconds, and there are several, all permutations and combinations of this. You can be used, and they are quite intuitive because this order represents what your input is in. Assigning time zone with _TZ is also super helpful. So we use Lubridate all the time for timestamp manipulation before we join our data sets. Next is something that makes our life very easy, is using the janitor package for cleaning up column names. So this is I have a before and after here. So these are column names of a data set before using the package. So this is again an air quality data set that we received. And this is elevation. You can see elevation, month, season. These column names are really descriptive, which is great. PM 2.5 daily mean, PM 2.5 11 hours, 14 hours, 10 to 14 hours. So these are not bad column names. They're very descriptive, and if from this point of view of English, like, they're understandable. But when you start typing in these as variable names or column names, you see some inconsistencies. For example, there is dash and a gap here. Then there are capital letters and small letters, and then there is gaps and dash, and then many column names starting with digits instead of alphabets. So I can load the janitor library and then just ask to clean names, and this is what happens after that. So by default, it will clean up all the names, as in convert them consistently to snake case. So all lower cases separated by underscore, all the gaps are gone, all the dashes are gone, they are all replaced. Any separation is replaced with underscore. So this is just more consistent, and when you're calling each column, it's just more systematic than to include in analysis. Okay. Next, we use Plotly a lot for to make interactive plots. So ggplot is the default. Here I have an example of ggplot, and then what happens if we use Plotly after that. So I have a simple ggplot time series object. It's called plot1 here. I'm sorry about very fine font, but stay with me. The y-axis here is time. It's x-axis here is time. It's a time series, and y-axis is pollutant concentration. So this is what we get is a useful plot, a static plot from ggplot. And if I use Plotly, so I've just called library Plotly and then wrapped my ggplot object plot1 in ggplotly, which is a function. So that takes in a ggplot object and then converts into interactive plot. So now look, it's the same plot, it's the same information. Now I can scan, I can click on points and it shows the date and BC. So it shows more information on that. There's a lot you can do. I can zoom in, I can pan around. So suddenly I have this very nice interactive plot with just one command. And it's very useful if you're working with, again, high frequency data, big data, and you want to do more with a plot. Next set of interactive plotting is making interactive maps with the leaflet package. So I'll just do a quick demo of that. Yes. So this is a sample map of our study area. It's a background of OpenStreetMaps, and on this there is a leaflet map overlaid, and the colors show pollutant concentration. And if I click here, I can click on each point and see what the attributes are there. So I have one pollutant at 72, I have 55% humidity, and then I have this particle concentration. So this is again better than a static map. I can pan, go to a different area, I can zoom, look at this. So this is just so much more increased functionality using the leaflet map. So we'll go back here. We also use R for statistical modeling. There are many things we can just do with base R, linear, multilinear regressions with the LM function, logit models when you have categorical or binary outputs with GLM, PCA, principal component analysis using PRComp, There are many options for linear mixed effect models. We use the LME4 package more frequently, and then the general additive models or GAM models using the GAM package. We have not started exploring tidy models yet, but that's on our list. Since we're talking about air quality, there is this one package which is really cool and very helpful called Open Air by Carslow and Ropkins, and it's for air quality specific data. There is some really cool visualizations that you can do using that. So this one that we make very often, this is called a calendar plot. As you can see, this is a calendar from July 2019 to February 2020. And for each day, each box is a single day, and we can see this is the color signifies the pollutant concentration, and the arrow here is for the wind direction. So you can see the wind direction and magnitude from the size of the arrow. So this is just like this one single plot is doing a lot of work, and it's just really amazing and very informative to use. So if you work in air quality and if you haven't checked out yet, definitely check out the Open Air package. So you may have figured, or you may imagine that in this work we do there are a lot of repeat data analysis tasks. For example, for mobile monitoring, we take a car in a neighborhood and we map a neighborhood several days do many repeat measurements so that we have all we have accommodated for all the variations in that neighborhood. So it's one neighborhood measured over several different days, many different times. Then we go from one neighborhood to another and then measure that several different times. And so these repeat measurements, so there are these daily measurements that we take, and the data analysis tasks are pretty much similar from one day to another. Make sure the timestamps are consistent, join the data, plot the data to see if what happened that day, were there any anomalies, do quality assurance, quality checks. So to simplify these repeat tasks, we have developed some Shiny apps. One is for the mobile monitoring, so the data from multiple monitors. And what this looks like is on the left, you have the option of uploading your data from different sources. So for the location data, the pollutant data, the weather data. And once you do that, the app will automatically generate a joint file. And not only that, but also a statistical summary and time series plots, maps. So this really reduces the computational time from many hours per day to a few clicks per minute. So here is a link for that. It's called MMAQ Shiny. Another app that we have developed for stationary data. So this is called PolluCheck, and it's to facilitate analyzing open source air quality data from India and from many other global sources as well. So once again, you can upload the data and specify data cleaning parameters, and it will generate a summary, statistical plots, linear regressions, and many other. And we have also integrated Open Air, so the calendar plots, you can generate those using the Open Air functionalities through this package as well. So if you have in your area, you have Open Air quality data sources, take this for a spin and definitely give us feedback. And if you want to learn more, please attend Aditi's talk, elevator pitch, which is in a few hours, and ask more questions on that and give us feedback. Okay, so from data analysis, I want to switch gears and talk about using R as a workflow tool to organize and share our work. So the first thing, and maybe you already do this, but before we used R, we just like organizing our work in our separate folders on our computers, and everyone had a different system. But using creating an RStudio project for each new project and just each new bundle of analysis has been super helpful. So that's how we start every project, and now they're organized like that. And using GitHub for version control, and then initiating the GitHub with a README file, which in the beginning, it contains a project description, file name description. So what are the file naming conventions? Every project may have different naming convention based on the dates, on the region, on the purpose, and other metadata. So once after initializing, we keep the README file continues to evolve as our analysis evolves and as we complete it. So using the R projects version control plus README, it's really helped streamline our organization. And then reporting with R Markdown. So that has been a really game changer, I think, in terms of if you already use R Markdown, you know how useful it is to have code and outputs side by side, in facilitating sharing and reviewing by other people who are coding or who are reviewing your results, or collaborators. For reproducible analysis, you can reproduce an analysis with a click of a button, make few changes, and reproduce it again. And different output formats are possible: Word docs, PDF. Of course, the HTML format has most of the functionalities, so that's really useful. Some features that we find particularly nifty for us is just this inline text. So if I want to summarize, include a summary of this is the mean, or this is the standard deviation of this parameter inside my text, and I don't want to write it manually but have it computed, I could use the inline text function. So here is, if you have not used it, here is a simple here is an example. So I have this. This is all code, and this is a generated output, because this slide show is also R Markdown document. So this is all code and output here that you're seeing. So I have assigned A is 2, and I want to say I have A number of cats and A plus 1 number of dogs. And I include those expressions in this codes along with R. And then R Markdown knows to evaluate that code. So I have, this is the output. So this is what you type as your code, and your R Markdown report output will have 2 cats and 3 dogs, which has taken the value from A and this from A plus 1. So if you include an expression, it will be evaluated like that. And in your final report, it just looks like plain text, but it's just like such a clever thing that if you want to include a number which has been computed and don't want to type it, changes, this very nifty. Another aesthetic feature which is really cool is just having table of contents, and then a floating table of contents. So it's just with these 2 commands, TOC is true and TOC float is true. I'll just give you a demo here. So this is a report with floating table of content. By floating, I mean as you go further down the report, your table of content stays with you. So you can actually use it to navigate through the report, no matter how long the report is. So that is very useful. And then something else that we have been playing around with a little bit is, remember our stationary map of Bangalore low-cost sensors. So this is, we have around 40 plus sensors, and for each sensor, we have to very frequently, every few weeks or monthly, we have to generate diagnostic reports, like is the sensor healthy, or is the data reliable? So that means data cleaning, analysis, plotting some time series, regression, comparing it with reference regression. And the analysis looks the same for all of whichever sensor you choose, the analysis will be the same. So we are playing around with the idea of using parameters using the each sensor as a parameter and then generating individual diagnostic reports using a single R Markdown file. So if that works, that will again really simplify the analysis. So that's all today for the analysis part. I'm really excited to share with you what the final part of the talk, which is stuff that we have learned from the R community. And these are the things that, we did not set out to learn these lessons, but we are so glad that we did, because it has really, I think, improved our work for the better and just our approach for the better. So first lesson is just, importance of community. Like today, if anyone asks me if they're on the fence about R and would learning R be worth it, or should I spend time, and my usual response is it's definitely it's worth your time. You won't feel that the time is wasted. And also our community is amazing, so you should definitely learn R for the community. And 5 years ago, if someone had told me that you learn this technology because community is amazing, I would not have been able to relate to that, because that's just two different things. That were two different things in my mind that I couldn't connect. Like I want to make cool plots and I want to learn the statistical method so I can use it in this paper. I don't know. I don't know about this community aspect. I can't relate to that. But that could not be further from the truth today. Just the community, and you all of you are attending here who are part of our community. So thank you for that. And it's just the support and encouragement that we have received from our community has been amazing. And when I said in the beginning that we learned everything on the job in terms of R, I think the other thing is also that we learned many things from the community, just many techniques, many approaches, things to think about, and we are just so grateful. Whether it is the Our Lady Slack channels, when you're stuck, you post a question and there's so many helpful responses. The minorities in our user community, which is just amazing and encouraging. And if you identify as a minority in R, please definitely consider joining this amazing community. The book clubs, the meetups, the Tidy Tuesdays, and the code of sharing, the norm of sharing your code that's just like such a good spirit. And we all share that now, and we have learned so much from that. So that's an amazing, very invaluable lesson that we have learned. Second lesson is using artwork for teaching. So when we think of data science or even like air quality, that and artwork, it just doesn't fit together, at least, in my mind, it didn't used to. But now I have, now my mind has changed, our mind has changed. And the main inspiration for that comes from Dr. Alison Host's work and her, amazing, fuzzy, delightful R monsters, and her artwork for beginner concepts as well as like really sophisticated concepts like clustering and statistical analysis. And all of this are just so useful in making not just learning, but also teaching R, and just making it so much more friendlier and more fun and more accessible. So this has been very, very inspiring for us. I also want to give a shout out to the Teacup Giraffes project by Wallum and Leon. The link is right here. In their own words, it's a delightful series of modules to learn statistics and R coding for students, scientists, and stats enthusiasts. And it's truly, truly delightful. So they start, if you're not familiar with this, they start with these cute giraffes, measuring their length on each of these two islands, and then looking at the differences of populations. So through like these, through this kind of storytelling, gently introduce basic concepts like distributions, population distribution, standard error, ggplot. And so if you're a beginner yourself, or if you're looking to teach beginners, please definitely check this resource out. So examples like this, like they have made our learning fun, our learning fun, and as well as really made us think about how to push this envelope of teaching and making it less dry when it comes to R and stats, and a bit more friendlier. So that has been great. And the third lesson is this open source and collaboration. So how to operate in this ecosystem, and like how to think about sharing code and making that collaboration less painful and easier by following some coding practices. So again, this is what we try to follow to make coding practices easier. And if you have more insights, if there's stuff that you do, I would love to hear that in chat. So using projects and version first, like I mentioned, version control for organizing, and really exhaustive descriptive README files. So if people read them, especially in this pandemic situation when you are not there to explain many times and people are working in time inconsistent manner, having that README file that is exhaustive to handhold someone new has worked well. Then just coding, like following tidyverse style guide for code, so your code looks consistent, it's easier to understand, and consistent naming with functions and objects, and commenting code for yourself and commenting code for others, for our collaborators, where and definitely explaining the why of the code, like why did we do this analysis and why did we do that analysis when we did that one. And especially when we are adding new packages into code, when new packages and new libraries that are function task specific, so just commenting that what that library is for. And last but not the least, not hard coding file locations. So no file locations which says like my C drive and my computer and my folder inside the code, because that will not work on someone else's computer. So using relative file paths with the package here, that has really simplified this, using relative file paths in the code. So these are some practices. I won't say that every code on my computer right now follows this, but at least before we share it with others, we try to go through this checklist to see that all of this is satisfied. In terms of what next, this is some things from our list. So one thing we want to do is a book down project to organize all of our field protocols and code project-wise. So for each project, this has been kind of this ambitious project that we have, I think we are working towards, so that like we can bundle it in a way that if next another group wants to work on mobile monitoring, we could just transfer this, do this knowledge transfer in a way that it is can be well followed. And we do want to explore tidy models as we get more into modeling and machine learning for building air quality models. And the third thing that I've written it as a bullet point, but it's more like a reminder for all of us, our team, that is thinking about accessibility. This has definitely been a blind spot, and really it's the interactions with our community on Twitter and Slack that has sensitized us to this, to think more and to have considerations for accessibility in our workflow. So for this presentation, I've tried to add alt text in the images. If they don't work for you, please let me know, because we definitely like to correct that. And that's like, this would be a work in progress, but we would like to be conscious and start thinking about that now. So with that, I would like to acknowledge the resources that I've used for this presentation. Sharingen and Sharingen Extra. Sharingen Extra has some really cool features like the tab sets and tile views, and it really adds a lot of functionalities to Sharingen. All the images and the one like on the side, the background images are from raw pixel, which that are publicly available. And the logos in the schematics are from the Noun project. And this is a Creative Commons project, and these are publicly available. I would also like to thank our research partners and funding collaborators, without whom the work would not have been possible. And yeah, with that, I leave you with this image of what it feels like to be a part of the supportive R community. And thank you so much. Thank you so much for being here today.
Thank you so much, Meenakshi, for the wonderful talk. I have a few questions lined up. The first question is by David. Can you give some examples of research questions that you have been able to answer with R?
Yeah, so some of the questions that one thing that we wanted to ask is, you saw those the maps that I'm calling stable maps. So one thing was that we wanted to know how many drives in a neighborhood is enough to make reliable stable maps that capture most of the variation. So that's one thing. I think that's one of the first questions that we wanted to ask, and so we did that using R. It involves first taking a data sets of, say, 30 drives in a neighborhood, and then you take 2 drives and 3 drives and 10 drives and see if they match with the 30 drive data set. And so it involves sampling and resampling. And so all of that work, we did that in R, and that the answer is just like in research, there's never a definite answer, but you get some answers and more questions. So the answer was, it depends on the neighborhood, and depending on the variation in the pollution, the number of drives that you need will change.
Yes, thank you. The next question is, how often do you update the stationary data for its Shiny app?
So for the Shiny, the stationary data. So the stationary data, we don't collect that data. That for the Shiny app, that data is publicly available already. So speaking of those collective platforms, it depends on who is putting out the data. Sometimes the federal agency, and depending on the type of monitor, sometimes most of it these days is near real time, so it's every day or every few hours. But if it's depending on the technique, sometimes the older monitors, which are not real time, the data can be updated in a matter of days, or in a matter of days.
Okay, so thank you. The next question is by Arnold. You are working with several people in this project. How do you organize that you all work in the same way, and how do you use GitHub in collaboration? Who and when does the check in the GitHub happen?
Okay, so can I see those questions so that I can? I think that question had several parts. Could you repeat that question, Aditi? Sorry.
Yes. You are working with several people in this project. How do you organize that you all work in the same way? And how do you use GitHub in collaboration? That's one part.
Okay.
And the next part is, who and when does the check in the GitHub happen?
So I think it looks like Actually, we are not many people. So we are actually a very small team. So in terms of the people who do coding is really like right now is 3 of us who are doing coding. So it's not we're doing, so it's like, yeah, it's like a small team that's doing a lot. So we use GitHub not in the beginning, towards the later end, when one of us is like, say, hey, I'm done with this analysis and I think I've checked everything. Do you want to check if this runs the same way on your computer? So that's when we use GitHub to like, just like whatever my project bundle is, to just use GitHub so that nothing is missed and it all goes like if I'm doing, Aditi can just download all of that and then clone that and then see if something is missing, and then she can check for all, if I'm doing the best practices, if I have hard-coded file name, file directories and stuff, then she would change that and then I could make those edits.
Okay, thank you. I hope, Arnold, we have answered your question. The next question is, did you run into memory issues when storing all your air quality data locally in the laptop? Also, since the analysis can be replicated all around the world, have you thought of turning your analysis into a package?
For this, I would invite Aditi to answer the question. Aditi, if that's okay, because that work is led by you.
Yes, so we did run into memory issues, but not with data, but just when we analyze a lot of data, I did run into memory issues. But then I also learned about parallel processing. So I would keep all my course running for this mega work happening in my R studio. And so that is the first part of the question. And the second part, we have not thought about making it into a package. It never occurred to us, but then I'm sure we can definitely give it a try. Thank you for pointing that out. That's a good initiative. Yeah, I hope we answered your question. Okay. The next question is, I wonder if R is fast enough for data analysis in your case. I think you're dealing with big data. Do you use R in a cluster or on a single PC? I think that was something similar. And yeah, Meenakshi, do you want to add anything?
No, I think you answered that.
The next question is, could you please explain a bit what the here package does?
Yeah, sure. So if you just download the library here, like the here package, you will get, as soon as you download that, you'll get a message that here starts from your current directory. So here basically encapsulates what your current directory is. So if you're using it on a different machine, it will encapsulate that. So basically here makes the starting point of your directory as your current directory. And then from there, I can write that in this folder, my file is like within data, I have data, and then I have raw, and in that there's my file name. So I can just say here, within brackets, data raw here. So as long as if I transfer the same bundle, like if I upload it on GitHub and someone downloads it, it doesn't matter where on the directory where in their computer the file is, because when they use here, then again the path starts from here, which is their current directory, and from data and raw and the file name. I hope that vocal explanation was useful.
Yes. So the next question is, tidy models is a great tool for quickly trying different model classes, but the gains in the model performance are often marginal at best. What are your expectations from that tool?
Oh, that's thank you for that information. I didn't know that. I think it is just because we are working in tidyverse and just like having sort of streamlined way of doing modeling is something that we like to learn. And So that's just like a different way of writing code in the tidyverse, or like the tidy way of doing this. So that's why it's on our list.
Okay, so there's one more question. Do you need to update the Shiny code for cleaning data?
Aditi, do you want to answer that?
Right now, we don't have to update any Shiny code, but you can definitely pull a request in the GitHub repo if you want any more features of cleaning data to be added. Right now, it has a few specified cleaning options already inside the application. Yeah, I hope I was able to explain it clearly. Anything to add, Meenakshi?
No, I think that's good.
Yes, we have one more question. Do you think there are enough tutorials for going from beginner to intermediate R user, or do you see some gaps?
So I feel like I have gone from beginner to intermediate R just using online resources. Maybe not necessarily tutorials, but what have helped are the book clubs. So R for data science book clubs or advanced R book clubs, like within the R community. So being part of those book clubs, so it's more active learning rather than following tutorials. And I think once you start using R, then you get better at asking the right question. So again, it's like you get yourself in the data, like this is a question I need to solve. I know this much beginner R, and then I can do these things to become for intermediate R. Also, something that has helped is just reading other people's code. So that's why I just love Tidy Tuesday, and there are screencasts by so many people that are helpful, not just for visualization but also for tidy modeling. So I do feel like there are enough resources, maybe not in form of tutorials, but if not in form of tutorials, many other ways to go from beginner to intermediate.
Okay, thank you. There's one last question which will be taken. So Ashish says, I'm working on geographical weighted regression. Can your research help in my subject?
Actually don't know. Aditi, are you familiar with that?
I have seen geographical weighted regression happening for land use regression models or another type of land use regression models. But you can definitely get in touch with us. What do you say, Meenakshi? We can definitely.
Yeah, and the link to our GitHub profiles is are there like online on Twitter. So just like definitely get in touch. We are getting into land use regression soon, so maybe there's something that will be helpful for you.
Yeah. Can I add just one more question? So what did you use before there was an alternative to R Markdown? How did you get around that?
Before R Markdown. So before R Markdown, I would just like share my code, like the .r file, and if anyone asked for it, because most of the time it was not needed, like unless the collaborator is another a person who is actively coding, they are not asking for it. So it's really just Word, like Word doc or Google Docs or Power presentation. So it's like what I am able to share is only outputs. We still do that. And it's still useful to share with a larger with a larger set of collaborators who really who are like this, doing at a higher level of decision making, where maybe they are not coding and or they just want to look at the results. So what helps in Google Docs is what we can't do in R Markdown yet, is like this real-time commenting. So I want to say that even if someone is looking at in a time inconsistent way, they can leave their comments and then you can come back and address them. So for such functionalities, we still use Google Docs and a combination of our Markdown, but just with the HTML reports and with the interactive plots, it's just so much more information that we can communicate. So now I think a hybrid of both is what we are trying. We are doing, and it works depending on the who we are communicating with.
Thank you. Thank you so much again, Meenakshi, for the very interesting and engaging keynote. And thank you everyone for joining us today. Please keep the discussion and questions going on in the Slack. There is a channel key_Kushwaha. And during the break, we want to again thank our studio, the sponsor of the day. And the next session will be in 15 minutes on these tracks. And see you all again. Enjoy, Yuzar.
Thank you. Bye-bye.